Alright, let's welcome back. Today we'll look at worksheet 5B on center of gravity and stability. So, what is meant by the term of center of gravity of an object? Center of gravity of an object is a point to which the whole weight appears to act on. So if I were to draw an object, let's say, so the geometrical center of object where the two lines actually meet, use dotted lines. This is the center of gravity, CG, and that's where I can draw my weight. Okay. Which scale marking on the uniform meter rule? Meter rule means it's 1 meter or 100 cm. It's aligned with its center of gravity. So we have a meter rule, we take the middle mark. So if this is your ruler, you want to find the center of gravity. This center of gravity is usually at the 50 cm mark. So 50 cm mark. Okay. On the following diagrams, mark the position of the center of gravity with an X. Show how you obtain your answer. So you take one corner to the next corner, draw a dotted line. One corner to the other corner, you draw a dotted line. In the center where the line intercepts is your center of gravity. Similarly for here, now you just take the corner towards the center, takes the corner here to the center, and then you can repeat for the rest. You will get the point where you intercept, that is the center is your center of gravity. Remember to mark it with an X, read the instructions. I'm pretty sure some of you did not mark it with an X, okay? All right, question 2. You're supplied with a plane mirror, concave, and a convex mirror. 3 small rubber balls indicate where will you place and illustrate the equilibrium. Okay, stable, they already give you the clue, stable, unstable, neutral. So figure 5.10, the center of gravity is in the middle here. Let me draw for all of them. Okay, so the test here is to give it a push. So if we give this a push, what will happen? Center of gravity will remain at the same height, which means that 5.10 is neutral. Now how about this? If I give it a slight push, now the ball is here. Originally center of gravity is this height. Now your center of gravity is higher. So center of gravity rise, it should come back. So this is stable. Let's look at the last one. If I give it a push, it should come here. Center of gravity originally is here. Now it's here. Center of gravity is lower. So when the center of gravity drops, it keeps dropping. It is unstable. So we look at the height of the center of gravity to determine whether it's stable, unstable, or neutral. 3. A pendulum at rest is in. So a pendulum is one that swings on the string. Okay, when it's at rest, it's in the stable equilibrium because if you push it a bit, it comes back to its original position. Center of gravity will also drop back down. A pen balance upright on the tabletop. So you take a pen now, you balance on the table, and you realize that it actually topples. Why? Because the center of gravity keeps falling, it's unstable. Sphere at rest on the horizontal surface is neutral because center of gravity is always at the same height. The center of gravity always at the same height. Okay, so let's check this. A, type of equilibrium is stable. Why? Because there is on the bigger base. Height of center of gravity when object is tilted slightly. Center of gravity originally is here. If you tilt it, center of gravity will go up a bit. Oops, sorry. Let's draw that again. It's worse. Okay. Whatever the case, the center of gravity will become higher. Okay, higher. Final position returns back to its original position. Why? Because center of gravity still cuts through the base of the object. The center of gravity, the line of action of the center of gravity will cut through the base of the object. Okay, let me draw again so that I can explain to you better. Imagine the bottle is tilted here. Original center of gravity, now center of gravity is here. Center of gravity, there is the weight. Your line of action is the dotted line. Line of action is still within the base. Where's the base? The base is here. If it's still within the base, it will give it a turn, a moment this way. This is clockwise. And in this case, it will return back to its original position. So it's stable. Next, it is unstable. Why? Because the height of the CG when it's tilted will be lower. So imagine if I tilt it. Center of gravity here. Now center of gravity should be slightly lower. lower, it will topple. Next one is neutral, cause center of gravity is the same, stable in any position. Okay, last one. Explain why the base of the Bunsen burner is designed to be large and heavy. So large means there is a wide base, heavy means there is a low center of gravity. So the heavy base ensures that center of gravity is low. Okay. While the wide base ensures that the center of gravity lies within the base. Wide base ensures that the center of gravity lies within the base of the Bunsen burner if it is tilted. So that means you have a Bunsen burner. Now in center of gravity should be here. This is the weight. Let's make this bigger. Now what happens if it's tilted? If it's tilted, center of gravity will still lie within the base. Okay, cause this to turn it back down here clockwise. Because center of gravity will still be lie within the base, it will give it a clockwise moment and will cause it to be more stable. Okay, so always when we explain, talk about the center of gravity being low, talk about a wider base that allows the center of gravity to be still be within the base area. Okay. All right. So today we'll end here. Thank